one of the things that I wanted to do was, I wanted to um, uh, add the feature to my engine that will allow a character to navigate a path, a navigation mesh basically, and from one point to the end, from the starting point to the target point, right? And for example, here I have my two characters, and here's the plane here, um, I don't know, the terrain, if you want to call it like that. And let's say that there is a wall between my two characters, right? How do I make my this character? Um, Number one, calculate the best path, the most optimal path from here to my this character, and secondly, how to actually direct the characters to take the particular path, right? Um, so how you do this is basically you have to implement an algorithm called the A star pathfinding algorithm. The algorithm is not really that hard to understand, and it's not hard to implement either. Again, it takes a little bit of peripheral code that you have to implement, but aside from that, it's very simple to to grasp. All right, so the first thing that you need to do is you need to generate a navigation mesh, right? A nav mesh, that's how they call it. Now in Blender, this is quite simple to produce. Well, basically, all what you need to do, by default, when you open Blender, Blender is gonna be in this mode, Blender render mode, right? But actually, all what you really need to do is if you go to Blender game, and then click on this icon, which is called scene, and then all what you do, you select what's going to represent your field or your plane, and you simply click build navigation mesh, right? So by clicking navigation mesh, you're gonna get something like that, and there you have it. That's your navigation mesh. And the A-star pathfinding algorithm is going to use this nav mesh to calculate the optimal path. All right. Now, before I explain to you how that works, I want to talk to you about something really quick. I'm gonna break it like this. As you can see here, we get like bunch of triangles or faces. I want you to keep this in mind. Each of these triangle is considered a node in the algorithm, and the triangles that are next to your particular, let's say you are processing this particular node right here, right? This one. You also need to keep in mind the neighbors of that particular node. So the neighbors will be the triangles that are adjacent to that particular node, right? You need to keep that in mind, and I'm saying that to you because I'm going to explain the whole algorithm in a second. All right. So number one thing that you need to do is you need to export this navigation mesh. All right. Aside from your normal characters that you have here, you need to also import let me delete this one because I already have it here. So aside from your models and everything that you have, you also need to export the navigation mesh. What I did is I actually wrote, I modified my digital asset exporter script, and I modify in such a way that you can also now export the navigation mesh. So if I go to export, you get the option to say navigation data, right? Not only mesh data, but also navigation data. And there you have it, right? So you export it, and it goes into your engine, in this case in my engine, and from that point on, you will read the particular node and the neighbors and the position and everything, and on and on. All right, so let me show you how everything works first. Okay, I did something here, so to explain it to you how it works. So this is a screenshot of my models with the navigation mesh, right? So the first thing is that we needed to export the navigation mesh into the engine, and the main things that we are concerned about is the particular phases of the nav mesh, right? The nodes. We're going to process those, right? During the export, what I do is I read every single node, and I basically every node is represented as a class in my game engine, and you can call it a nav mesh node class, right? And some of the data that it contains are the index of that node. You want to keep track of that index. It makes it life a lot easier. You also need to store the position, obviously, of that particular node, and you also need to store the neighbors of that particular node, right? Now this is where the idea of storing the index of the node comes in handy, because I don't store the whole class of the neighbor. I just store the index of this particular node. Blender will usually assign a node by itself, so this one could be 0, 1, 2, 3, 4, 5, 6, 7. So all what I do is I just read what's the neighbor of this particular phase, and I get that data, and I'll just store it here. Actually, I think I have it here. Oh, I have an example here. It's cool. So here's my node, a particular node that I have. It shows index 0, and then I store the location of my node, and I also store the neighbors, right? But as you can see, I only store the indices of those neighbors. I don't store anything else. I don't store no data, but just the indices. Later on, I'll just reference them when I'm building my whole nav mesh. All right. So once you have that and you have processed all of the node, then you are going to store all of those nodes into a container, which belongs to your navigation mesh class, right? A nav mesh. My nav mesh class in my engine has a container which stores all of the every node in the particular navigation mesh that I exported, right? And we use that in the A-star pathfinding algorithm. All right. Now let me explain how the A-star pathfinding algorithm actually works. Okay, so let's say that you want to go from this node to this particular node, right? Obviously your character can take this route, right, which can go all the way like this, or you can take this route right here. Obviously, just by looking at it, you know that the most optimal path would be this one, right? But how do we tell the characters to do that, right? And the star pathfinding algorithm actually informs the character which path to follow, doing the following. Let's say that this is I just want you to make sure that you guys can see that. All right, so let's say that this is my current node, this is my starting node right here, right? So you said your starting node as your current node, okay? And then you check, is my current node my end node? And in this case it is not. If it is, you obviously stop, but in this case it is not, right? So then what you do is you access the neighbors of this node, right? And the neighbors of this node are going to be these two triangles right here, right? And what you do next is you compute the total cost, all right? And that's one of the differences with the A-star pathfinding algorithms in contrast to other algorithms. You compute the cost. Now, there are basically two costs that you need to compute. Number one, the first one is called G cost, and that's the cost from your current node to the starting node, right? So my distance, basically, you compute the distance between this node to your starting node, and that is called the G cost. Then you also compute what is known as the H cost, and that's the cost from this node to your end node, right? And that's the distance that you compute. And then you just add them up, H cost plus G cost, and that will give you a total cost, or F cost. So what you need to do is you compute the F cost for each of your neighbors, right? And you select the neighbor with the lowest F cost. That's the neighbor that you want to select, all right? And then you basically start the whole process all over again. Okay, so now let's assume that my neighbor here, this one was the one with the lowest F cost, all right? So now what I do is I set this node as my current node, all right? And then again I test, hey, is this node my end node? Well, it is not. So you basically keep on going, right? And then you compute the F cost for each of your neighbors for the current node, right? You compute the G cost and the H cost. So you compute this one, and you will also compute the node for this one. However, you don't have to compute it for this one anymore because it was already processed, right? So you don't have to do that anymore. So you just select this neighbor, which is going to be the lowest F cost, and you repeat that whole process over and over again. And I know I'm simplifying things, but that's basically the whole idea, right? And eventually what's going to happen is that the A-star algorithm is going to find the most optimal path because of the F cost, the total cost, right? Eventually, the algorithm will basically trace the best path from the starting node all the way to the end node. And all what you do at the end, once you have reached that particular end node, is you trace back, right, all of the nodes that were involved in finding the optimal path, and that's the path that you use. Now, before I finish this, let me tell you this. My explanation, wasn't. My explanation could, about the A-star pathfinding algorithm was very simplified, right? And I want you to, if you are interested, I want you to go to YouTube, and I want you to actually Google the A-star pathfinding algorithm by Sebastian Log. I think that's how you pronounce his last name. A-star pathfinding algorithm. Now, his explanation is amazing. He even gives you the pseudocode of how everything works, and he will basically tell you exactly how everything it works, and using animations. And now this is taking a little bit longer, by using animations. And let me tell you this, when I watched this video, I think I watched it like 5 times. The first time I understood it because it's so logical, the way how he explains it. But basically I was able to implement the A-star pathfinding algorithm using his explanation. It was very simple, it wasn't complicated at all. So you may want to watch that. Let me just, I think I'm gonna stop this. Okay, I'm just gonna close this. All right. All right. Now, one of the things that that is going to take a little bit of work is, you know how how I told you that you need to compute the lowest neighbor, the neighbor with the lowest f cost, right? Um, and in this instance, um, the nav mesh, right, doesn't have a lot of neighbors to compute, but there may be a point where a particular current node can have, like, I don't know, 5, I don't know, like a lot of neighbors around it, and you need to compute the f cost for each of each of them, and then as you are computing the f cost, you need to order them from the lowest to the maximum because you want the one with the lowest. Well, that ordering, right, may take a significant amount of time. It may slow everything down. So what you need to keep in mind is that you may want to also implement a heap data structure, so that way your engine doesn't take too long ordering the nodes with the lowest and the highest. So that's what I actually had to do. I had to implement a heap data structure and then do a heap sort after every pass, after every, once I calculated the neighbors and everything, I would do a heap sort, so that way my whole heap data structure will always give me the node with the lowest f cost in an instant. So you will have to implement that. So just letting you know. All right, so once you have that particular path, right, what do you do with that, right? Okay, so now this is where it is a good idea to have implemented, right, some basic AI steering behaviors in your engine before you do the A-star algorithm, right? Some of if you have been watching my previous Twitch episodes, I already implemented several of them, like arrive and seek, flee and wander and follow path and on and on, right? So it makes sense that once you have a particular path, right, to call those steering behaviors and apply them to your character. So basically that's what I did. So let me now go here. All right, so what I did is I created a particular class called navigation, U4D navigation, and within that class I have two steering behavior objects, basically the path follow and the arrive steering behavior, right? So this is how everything works. Once we have my path, right, which is the segments here, right, I called my path follow behavior, and what it does is this, right? It's, I have my character here, and it then predicts a position depending on my current position and my current velocity, right? And let's say that the behavior, the engine predicts my position to be at this location, right? How the path follow behavior, steering behavior works is that the first thing that it does is that it computes the closest point on my particular segment to my predicted position, right? Basically, it computes the normal to that. So this would be my normal point, right? And then what it does, it will add an offset, and the offset is a user-defined number that you give, right? So that would be my offset, and that will basically and it will assign that as my target position. So now my character, instead of moving to this predicted position right here, is going to just kind of turn and move towards this target position, right? And it will keep doing all of that as as it goes around the path. Now, if you go to my YouTube channel, I do have a whole live stream on how this particular behavior works. So I encourage you to go watch it. It should help you out with that. So basically, it goes all around, until it gets to the target position. Now, one thing that I added to the engine is that I figure, once you get to this position, to the end node, you probably want your characters to slow down, right? Or as approaching the target. I think that's a good idea. You can change it if you want to. It's up to you. So, but what I do is, once the character is on the last segment of the path and is very close to the character, I change the velocity, the speed of my character. So once it reaches this particular radius, my character will change the speed to 40%, and then if it goes closer, it changes to 10% of the current speed, on and on. So that way, when it gets closer to the character, everything slows down, and that's it. And basically that's how it works. So, well, how, obviously, right? That seems to be a lot of work to just do the navigation, right? Well, the whole point of a game engine is to make the life of a game developer easier, right? So what my engine basically takes care of all of the hard stuff, so that the developer can just focus on the mechanics of the game. So everything that I explained to you is actually accomplished within a few lines of code, right? Number one is, once you have exported a navigation mesh from Blender onto my game engine, you basically create a navigation object, right? That's the navigation object right here. Using U4D navigation, and you just do a new, and then the U4D navigation, and then you load a navigation mesh, right? You provide the name of the navigation and the file where you're going to store that. Basically, the name of the navigation is, you can have that in Blender. You can find that in Blender, which is here. I'm pointing it out, right? So once you have done that, if you want to set some options, you do that. Options such as the radius of the path, the speed that you want to change, whatever. But basically, this will load a navigation mesh onto the navigation object, right? Then, guess what? Or why you say, I want to compute the path from my character position to my target position. Basically, you tell them, hey, this is my target, my character. I want you to compute the path from this guy, from here to here, right? And that's all what you do. My character, and then the target, and then you just call navigation get steering, and the engine will basically direct, guide the character to follow the best path possible. And that's basically how it works. So let me actually give you an example of how that works. Alright, so here's the engine. Let me close this, and I'm going to turn on my controller because I'm going to press the button A to inform that character to start moving. Alright, so I'm gonna build this. Okay, things are is building right now, so let's just wait. It's taking longer than usual. Okay, right now it's loading up the nav mesh data and the model data and everything. All right, so I'm gonna switch to my screen to my Mac, and now you see that. So now I'm just gonna press the button A, which basically is going to inform the characters to start, basically to compute the path and to start moving, right? So just by pressing the A, uh, let me highlight this. All right, so A, and now you can see that the character starts to move all by himself. But right now, just it's turning a little bit wild. It's because of the particular radius and the offset that I gave to my path follow algorithm. But basically, as you can see, it's able to find the location, and boom, there you go. And you also notice that as it approached the character, it actually started to slow down, which is